In this video we will have a look at the software part of the hexagonal display. We don't want to have a look at the coding, but want to talk about the concepts which are behind the hexagonal display. The software tries to abstract the technical part from the design part to make it easy to create new patterns. To understand the concepts which are in the software, we need to have a look at the layout of the LEDs. This is how the LEDs look like on the board. I'll create some dots and fade the board away. This is how the software sees the LEDs. So each LED has a number and can be addressed by this number. To create a two-dimensional image, the computer needs to know the layout of the LEDs. For us, it's easy to see how they are arranged, but the computer needs to know the exact positions of the LEDs. We just store some coordinates. Now we can take an image, see which LED fits in the image, and light the LEDs accordingly. But where does this image come from? So the Arduino does not have enough memory to store an image. Furthermore, the resolution is much too low to show an image in good quality. And since we have this blurry diffuser on the top, we won't be able to show sharp images anyway, so that's not the right way to go. So one idea is to just draw circles always, and then we can calculate which points are on the circle. We can also create some soft edges on the circle, and then calculate the brightness of the LEDs accordingly. This will make it more fuzzy for our display, which is what we want. And one circle also does not take up so much memory, it just needs the coordinates and the size, that's all. So this is how it looks on the real display. So we see already, okay, it looks a little bit like a hexagon. But yeah, it's still a circle somehow. So when we decrease the size of the circle, we see, okay, due to the low resolution, it only changed slowly. But yeah, we can still see it's always a circle somehow. Some sizes look a little weird, but it's still a circle. So what can we do to improve this? So one possibility is to move it just around. And then we see, okay, due to the animation, it already looks better than before. This blurry tail you see here is from the software, not from the camera or the display. So it's intended to be this way, to make it more blurry. So let's see if we can modify the circle a little bit to make it more individual. So here we see the standard circle, which is just drawn. But we can also have a circle which is just the outline, and one which is decreasing from the center to the outside. The other way around is also possible. From the center to the outside it's increasing here. This one is just creating a blurry outside ring. And this one is using a sine wave over the radius to create some kind of soft ring. This one just decreases from the inside to the outside by a sine wave to make it more blurry. And for comparison, this is without any modification. So this is how it looks in the real pattern. So this should be some kind of cloudy sky simulation. So we have some circles here which are moving over the sky. So to make it a little bit clearer what happens here, I accelerated this pattern of the factor of 30. So the clouds are moving very fast. The normal speed is much slower. But you get a good idea how this pattern is working by just moving circles around. The initial position, size, and speed is randomly generated. Furthermore, the directions are randomly changed to make some kind of very random pattern. This pattern is not using any circles but a callback routine, which determines the color of the pixel according to the distance from the center. This pattern uses the circles with the ring structure, so they are starting in the middle and then moving outside and changing the color on the way. So it looks a little bit nervous in my opinion, but the low resolution of the display makes it not better possible. But it's still interesting somehow. Here we see a simulation of a fire. So we start with one pixel, fire pixel somehow, which is moving up. The trails are created by just fading out this one pixels over time. The program controls the color and the speed and also the movement of the pixels. So they are moved outside on the bottom and inside on the top again. But yeah, this doesn't look too much like a fire, so I think we need some more pixels here. So let's increase it to 4 pixels. So it already looks much more like a fire simulation now. But it's still somehow, yeah, I think not enough pixels. So just double the amount of pixels again and we see, yeah, we have some kind of fire simulation, which is really looking like a fire. And it also looks kind of random, since we also use random numbers here. How bright the pixel is, in which direction it starts, how far it goes up, and so on. So yeah, we can look at this simulation and it won't repeat itself. This pattern again is the callback pattern, so it's not using the circles at all. So I use a 90s plasma effect, which is used in PC and home computer demos. Basically, the calculation is based on the position of the pixel and some sign calculations. And then it's just creating some RGB value, which is put to the pixel. So it looks very nice because it's sometimes slow and sometimes fast. And the colors are sometimes very narrow and sometimes we have really huge areas with the same color. So it's somehow my favorite effect, even if it's not using the circles at all. Due to the hexagonal structure of the display, this fits very well to this pattern, because this pattern does never have some kind of straight lines. It always bends somehow, and this fits very well to the structure, because next pixel is never far away and it's not somehow over the corner or something like this. So we can have a nice picture here with a very low resolution. If you want to build such a hexagonal display on your own, just have a look at the Instructable I have linked below, and also have a look at the other videos in this row which show how this was built. When you have created a pattern for your own display, please let me know. Either create a pull request on the Git repository or write me a comment in the Instructable or comment here on the YouTube video. I would like to include this in my software and make it available for everybody. Thanks for watching and see you in my next video.